Okay, so you may have noticed when you're using an AK-74, the default ranging is set to 440 meters, as you can see in the bottom right of the screen. And you may wonder, why is it such an odd number? And that's the battle zero on AK-74. So the short 5-second explanation is the following. Let's say you're aiming at the target at the belt buckle, so half the silhouette size of the target, at anywhere between point blank and 440 meters. Then the bullet impact will be somewhere in the upper torso of the target. Now, this may seem like some really crude aiming mechanism. However, if you know the details behind it, I think you're really going to like it once you understand it. Okay, so next thing we're going to explain is how sight pictures work on iron sights. Okay, so by default, the AK-74 is a battle 0 440. That's the lowest setting. Then you press page up, and it goes to 100 meters, up to 1,000 meters. And let's say I have it at 100 meters. Now let's look at the side view. Okay, so here's how it works. You have the rear side post, it's that here, and you have the front side post. And a side picture, getting a side picture means that the tip of the front side post needs to align with the top line between those two notches. And then if you shoot at the range that is determined, that's where the bullet impact will be. And what may not be apparent from looking at a gun like that the bore sight, that's where the barrel is pointing at, is not exactly parallel to the side picture. Okay, let's increase the ranging to 1,000 meters. Okay, see the difference now? The rear side post is raised, and for the shooter to get a side picture, to align it again, that means if the rear side post is raised, the rear of the gun has to go down, and that means the front of the weapon, the barrel, is pointing further up, which means the bullet will fly farther. And that's what a side picture is. And it's even more visible if you use a grenade launcher. So let's say you have a grenade launcher at 50 meters. That's a side picture. Now you go up to 400 meters. And I can see the extreme difference in trajectory. And that is because a grenade launcher round travels at about 76 meters per second, which is about 10 to 12 times slower than an AK-74 bullet. And you can see it here. That's the rear and the front side post for the grenade launcher, and you can see how the theory is. You have sight line going through that, and bore sight going up like that. And if the grenade launcher is ranged to 400 meters, that means the sight line and the trajectory of the projectile will intersect at 400 meters. And another cool thing is if you take a PKM, the default ranging, if you just equip the weapon, is at 100 meters. But if you press page down, then it switches to 420. That's the battle zero for the PKM. Okay, now let's demonstrate how it performs with the battle zero. Last target won't even render, so I put the flagpole behind it so I know what I'm aiming at. Okay, switching to Game Master and pausing so the decals don't disappear. Okay, so 25 meters, it almost hits exactly where I'm aiming. At 50 meters, it's rising above the aim point. At 100 meters, it rises even further. 200 meters rises even further. At 300 meters, I think I may have entirely missed the thing, but it's most likely an aiming error because it's really hard to aim at that pixel. So the impact point would have been somewhere in this area. It's probably went off to the left a bit. And for the last target, not so much lower this. So I was aiming that area again. So the impact point is here. So what's interesting here is if the 300 meter target would have been ahead. What you will notice is that at 25 meters, it hits almost here. Then it goes further up to 300 meters. And then at 440 meters, it falls down again. And that's because the parabolic trajectory is not a symmetric parabolic. It's squeezed on the rear end. So you have the rear side post, front side post. That's the sightline. That's the weapon barrel pointing up. That's the trajectory of the bullet. It starts rising, then eventually it stabilizes, and then the air resistance and gravity overwhelm the bullet. It destabilizes and just falls to the ground. And to show why the impact point shifts, I'm going to move the target. So if the target is very close to the shooter, then the impact point is very close to the endpoint. As the target is moved away, the impact point rises above the endpoint. It keeps rising like this until it eventually falls down shortly before 440. And at 440, the trajectory of the bullet intersects with the line of sight. In-game, there's a pretty cool advantage to it. So let's say I'm shooting with Battle Zero on. I got tracers on. It's nighttime. I'm switching to 100 meters. Can you see what was different here? When I'm shooting with Battle Zero, most of the bullets, you can see the tracers, it was like a cloud of tracers above the needle over here. Which means when I was shooting, I could see where the impacts were as I'm aiming at something. And with the 100 meter setting, most of them were converging directly on the needle point. Which means less of your target is obscured when you're using Battle Zero at most distances.